Welcome back to geometry. This is going to be section 10.3. It's going to be a fairly easy one for us. We're going to be looking at properties of chords. So just a reminder, a chord is a line segment that goes from circle to circle, meaning a point on a circle like P to another point on the circle like Q, but does not pass through the center of the circle. So the line segment from P to Q would be considered a chord. Also, I just sketched another one on the same circle here. The line segment from R to S is also considered a chord. It goes from circle to circle without passing through the center. Okay, and so what we're going to have then is 4 theorems that deal with that deal with chords. All right, the first one, number 10.3, says that in the same or equal circles, 2 minor arcs are equal if and only if the chords are equal. Okay, now remember, if and only if, IFF, that's our abbreviation for that, if and only if, meaning this theorem works in both directions. So if the arcs are equal, then the chords are equal, or if the chords are equal, then the arcs are equal. And then I just wrote it in kind of an abbreviated form down here. Okay, so what this says is if chord AB is equal to chord CD, then arc AB is equal to arc CD. Or it works the other way as well. If the arcs are equal, then the chords must also be equal. Okay? Theorem 10.4, if one chord is a perpendicular bisector of another, then the first chord is a diameter. Now I know I'm not giving you much time here, but feel free to pause this video to get these 2 theorems down in your notebook. All right, the next 2 theorems, numbers 10.5 and 10.6. Here we go. 10.5 says if a diameter of a circle is perpendicular to a chord, then the diameter bisects both the chord and the arc. Okay, so what we're starting with is a diameter being perpendicular to a chord. So diameter of a circle has to be perpendicular to the chord. Okay, so in my diagram, the diameter is AC. Because it passes through the center, it's a diameter. And then you can see in my picture that that is then perpendicular to the chord DE. So the theorem says if the diameter is perpendicular to a chord, then the diameter bisects, remember bisect means cut into 2 equal parts, bisects both the chord and the arc. So if the diameter, so just a reminder, AC is the diameter, is perpendicular to a chord, so DE, then the chord gets bisected, so DF, so segment DF and segment EF are equal, so that's the first result. And then also arc DC and arc EC are equal. So both of those things are going to be true when a diameter is perpendicular to a chord. And finally, the fourth one, the last one for us in this section, is theorem 10.6. And it just simply goes, in the same or equal circles, chords are equal if and only if, again, remember that's a theorem then that works in both directions, they are equidistant from the center. So chords are equal if and only if they're equidistant from the center. Okay, so in my diagram, what this is saying is chord AB is going to be equal to chord CD if and only if the distances are the same away from the center. So the distance from the center to this line, this chord, and the distance from the center to this chord would have to be equal. So the chords are equal, A, B, and C, D are equal, if and only if the distances are equal. Okay? And again, feel free to pause this video to get those 2 theorems down in your notebook. Okay? So we're going to finish off then with some numerical problems. And I took a picture of a couple of them so that we have something easy to work with. All right, so I put 2 on this page. So let me just draw a line down the middle. And the question on this one is find the measure of arc BC. So that's what we're trying to find. BC, you can tell, is the arc that starts here at B and wraps around to C. So what's the measure of that arc? Okay, so what we have to do first is we have to use theorem 10.3 that says 2 minor arcs are equal if and only if the chords are equal. So what we have here is 2, let me choose my laser pointer. We have 2 chords that are equal. Chord AC is equal to chord BC, right? And we know they're equal because the diagram puts the tick marks on those 2 line segments. So we know those 2 chords, AC and BC, are equal to each other. Now what the theorem says is that then the chords are also going to be equal to each other. So arc AC is going to be equal to arc BC. So those 2 arcs are equal. So we just have to put that together with the fact that if we add up all of the arcs for the full circle, they would add up to 360 degrees. So if I put arc AC, and we can call that whatever you guys want, we could call that, oh gosh, I don't know, it's been a while for us, so we could call it something like holiday tree, plus arc BC, but again, that's going to be exactly the same as AC, so if AC is holiday tree, BC can be holiday tree, and then we just have to add the third arc, and that gives us an equation that we can then solve for holiday tree. 1 holiday tree plus 1 holiday tree is 2 holiday trees. We can move the plus 116 to the other side by subtraction. And so what we're left with is 2 holiday trees is equal to, what is that, 244? I should probably double check just to make sure I'm not messing that up. Yep. And then to get rid of the times 2, divide by 2. So each of the holiday trees is going to be equal to 122 degrees. So to answer our question then, the measure of arc BC, same as holiday tree, is 122 degrees. Okay? Alrighty. My second example, we have a circle with a square inscribed inside of. All right, and what we're being asked for is the measure of arc LM. Okay, so the arc L to M starts at L, goes around the shortest distance to M. All right, so we're looking for the measure, of that arc. And again, using theorem 10.3, if chords are equal, arcs are equal. So what we have going on here, guys, is not just 2, but actually 4 chords, JM, JK, KL, and LM. All 4 of these chords are equal to each other. So theorem 10.3 says if all the chords are equal, then all of the arcs are equal. Therefore, using some tick marks here, we could say that arc, JM, is equal to arc, KJ. That's also going to be equal to arc, KL, and that's going to be equal to arc, LM. So in other words, all 4 arcs are equal. So if we just give the arcs a name like, G, then all of them would be G. And then again, just using the fact that all of the arcs together are going to add up to 360 degrees, we could just simply add G plus G plus G plus G, and that sum must be 360. So when we actually solve the equation, 1G plus 1G plus 1G plus 1G is 4G. And to get rid of times 4, divide by 4. So G is going to be equal to 90. All right, and since LM is represented by little g, LM is also 90 degrees. Okay, probably not a big surprise once you see the answer that each of those individual arcs had to be 90 degrees. Okay, again, feel free to pause the video if you're putting any of these examples into your notebook so that you have them available for your test. Okay, here's a third example using the same theorem. Again, the idea, instead of tick marks, though, we just chose to use 7s. So the 7 here says that the length of chord AC is 7 long. Over here, the length of arc BC is 7, and therefore you guys can clearly tell that these two chords are equal to each other. And again, our theorem says if the chords are equal, that forces the arcs to be equal. And again, using the fact that all three of the arcs here are going to add up to 360, again, just call these something. Just for a little variety, let's just call it Diet Mountain Dew. Haven't done that one for a while. So what we just simply have is Diet Mountain Dew plus Diet Mountain Dew plus 130 has to add up to 360. Again, giving us an easy equation to solve. 1 Diet Mountain Dew plus 1 Diet Mountain Dew is 2 Diet Mountain Dews. Move plus 130 to the other side by subtraction. And to get rid of times 2, divide by 2. So Diet Mountain Dew then is going to be equal to 230 divided by 2, so 115. And therefore the measure of arc AC is 115 degrees. Okay. All right, so hopefully those are a couple of easy examples to get you going there. And then we just have just 2 more that I wanted to look at. And let me pick red, maybe that'll stick out, be easier to see. All right, so on number 7, we're supposed to find the value for x. And the idea is that we have a diameter, and I'm going to try to highlight the diameter in red. So the diameter here starts at F, goes through the center at J, and then ends on the circle. They don't give us a letter here, but ends on the circle. But because it goes through the center, this is then a diameter. Okay? And then you can see that because of the 90-degree box, that's perpendicular then to the chord EG. So we're using our theorem 10.5 that says if a diameter is perpendicular to a chord, that's exactly what we'd have then, right? Diameter, let me pick my laser pointer. Diameter perpendicular to a chord, then what was the result? Then that diameter bisects both the chord and the arc. Now in this example, we don't care about the arc, but we do care about the chord. The diameter bisects the chord. And if something is bisected, that means it's cut into 2 equal parts, which tells us that this part of the chord, 3x plus 16, has to be equal to this part of the chord, 12x plus 7. And since they're equal, we create an equation. And whenever we have an equation, we can solve it. So I'm going to choose to move the variables to the right-hand side. The numbers to the left-hand side. And then to get rid of times 9, divide both sides by 9. And so the value for x then that makes this true is 1. Okay? All right, and then my final numerical example for this section is going to be this problem numbered 8. And again, it's asking us to find the value for x, but this time we have to use theorem 10.6, which says, in the same or equal circles, chords are equal if and only if they're equidistant from the center. So what I need to highlight for you this time is that the distance from the center to chord AB is equal to the distance from the center to chord DC. How do I know they're equal? because of the tick marks. I'll highlight the tick mark in red. So these two distances, E to chord AB and E to chord DC, are equal. You can see that by the tick marks. And what the theorem says is, if those distances are equal, then the chords are equal. Therefore, the chord AB, which they express as 3x minus 11, has to be equal to the length of chord DC, which they express as x plus 9. Again, giving us a very easy equation to solve. We can move the variables to one side, numbers to the other, and to get rid of the times 2, divide by 2. So the value for x then must be 20 divided by 2, or 10. Okay? So those are a couple of numerical examples that go along with section 3. So you now should be able to go ahead and do the work for section 3 in your textbook. You have all the problems on your assignment sheet. All right, and tomorrow, Thursday, is going to be a work day. So if you noticed in Google Classroom, we've now looked at sections 1, 2, and 3. And then Thursday is going to be a work day to make sure that you have some time to get yourself caught up on any or all of those assignments. Okay? So hope this finds everybody well. Keep having some fun doing some math, and we'll hope to see you soon. Bye.